Hello friends, I am Professor Sudhir Yadav from MGM Jawaharlal Nehru Engineering College, Aurangabad. Welcome all of you to this lecture on flow measurement. So before proceeding to the classification of fluid flow meters, I want to explain about what is the fluid. Fluid is nothing but that is a liquid and gases is called fluid. And fluid is used everywhere in different industries. So how to measure this fluid flow? That is very important part. So your fluid flow rate meter is classified in two types, that is volumetric flow rate and mass flow rate. Volumetric flow rate is also subclassified in differential type, displacement type, variable area meter, inferential meter. Differential type is also subclassified orifice plate, venturi plate, PITOT tube, dowel tube, flow nozzles. Displacement type, rotating disc, oscillating piston type, variable area meters, that is a ROTAMETER. Inferential meter is also subclassified hot oil anemometer, turbine meter, and target meter. Another classification of flow meters, that is a differential pressure, positive displacement, velocity, mass, and open channel. We are only interested in orifice plate, venturi tube, flow tubes, PITOT tubes, rotameter, and wear and plume. So variable head or differential meter, already we have seen these six different instruments under the heading of differential meter. So variable head or differential meter is also defined as it works on the principle of partially obstructing the flow in a pipe. This creates a difference in the static pressure between upstream and downstream side of the device. This difference in static pressure is measured and used to determine the flow rate. Next is head flow meter. Head flow meter operate on the principle of placing a restriction in a line to cause differential pressure head. Differential pressure which is caused by the head is measured and converted to flow measurement. Device in general can therefore be termed as obstruction type flow meters. Now see the diagrams. Variable head or differential flow meters. There are four different meters is shown. First is venturi meter. Second is orifice plate. Third is flow nozzles. Fourth is rotameter. Now your venturi meter is divided in four different parts. This is your upstream section. This is a diverging cone. This is a throat section. And this is your downstream side. Now next is orifice plate. So orifice plate is also divided in three parts. That is a upstream section, downstream section, and this is some diameter of this section is reduced. It is known as a vena contracta, and it is attached by a manometer. It contains manometric fluid, which shows the difference in height of manometric fluid. By using that, we can find out the pressure. So next is flow nozzles and rotameter. So these are differential meters. Details about these meters we will see in next slide. Merits and demerits of differential flow meters. Differential flow meters are simple to make, containing no moving parts. Their performance is well understood. They are cheap. They can be used in any orientation. They can be used for most gases and liquids. Sometimes do not require calibration for certain applications. Demerits. Rangeability is less than for most other types of flow meter. Significant pressure losses may occur. Output signal is non-linear with flow. Discharge coefficient accuracy may be affected by pipe layout, and they may be suffer from aging effects. So these are the merits and demerits of differential flow meters. Next is orifice meter. Orifice meter is a conduit and restriction to create a pressure drop. An hourglass is a form of orifice. In order to use any of these devices for measurement, it is necessary to calibrate them. This is a pass known volume through the meter and note the reading in order to provide the standard for measuring other quantities. An orifice in a pipeline is shown in the figure with manometer for measuring the drop in pressure. As fluid passes through the orifice, minimum cross-sectional area of the jet is known as a vena contracta. Now just see this diagram. In this diagram, this part is called as that minimum cross-sectional area and this part is called as a vena contracta. Now see the working of orifice meter. As fluid approaches the orifice, pressure increases slightly and then drops suddenly as orifice is passed. It continues to drop until vena contracta is reached and then gradually increases until at approximately 5 to 8 diameters downstream, a maximum pressure point is reached and that will be the lower than pressure upstream of orifice. So decrease in pressure when fluid passes through orifice is a result of increased the velocity of gas passing through the reduced area of orifice, and when velocity decreases as fluid leaves the orifice, pressure increases and tend to return to its original level. Pressure drop across the orifice increases when a rate of flow increases. When there is no flow, there is no differential. Differential pressure is proportional to the square of its velocity. Next part is orifice plate. It is different types of orifice plates we are using, that is a concentric type, eccentric type and segmental type. Concentric type is mostly we are using for gas, liquid and vapor. Eccentric type we can use for when there is a clog will occur, at that time we can use the eccentric type. Segmental type of orifice plate is divided in three different types, that is square edge. Square edge you can use for the Reynolds number from 500 to the 10,000. Quadrant we can use for the Reynolds number for 250 to 3,300. And conical for the Reynolds number typically ranged from 25 to 75. So next equipment is Venturi meter. So already we have seen this diagram. Venturi meter or Venturi flow meter is a device used to measure the velocity or flow rate of fluid flowing through the pipeline. Venturi meter consists of flow using Venturi tube. As liquid flows through the pipeline, device measure the pressure of liquid before it enters the Venturi tube and it exits the constricted area. These measurements are then compared to the figure. Volumetric rate of fluid. Flow meter is commonly used in plumbing applications to determine the flow of fluids such as water, gas, propane and oil. Now just see the diagram. So in this diagram, that your Venturi meter is divided in different part. Upstream section, your diameter is shown by capital D, then is converging cone, then throat is there where diameter of this equipment is very less, it is shown by small d, then that is a diverging cone, and lastly downstream section. Now upstream section and throat is connected by a manometer. Manometer will contains the manometric fluid, and due to the difference in pressure, it shows this height in difference through this manometric fluid. So by using that height difference, we can measure the flow rates or velocity. So comparison of Venturi meter and orifice meter. Orifice reducing element is sharp edge, while Venturi is a tapered tube. Permanent pressure loss of orifice is 65%, while Venturi is only 10% loss. Venturi tube is less sensitive to Reynolds number and gives more accurate measurement when pressure flow varies over wide range. Venturi tube is less affected by dirty fluid, which build up the deposit at the orifice plates and pressure taps connections. Venturi tube meters is more costly compared to orifice plate. And requires the greater length of pipeline. Orifice plate is relatively easy to change the new range. So next part is PITOT tube. So this is the PITOT tube. In PITOT tube is also known as a PITOT probe. Is a flow measurement device used to measure the fluid flow velocity. PITOT tube was invented by French scientist Henri PITOT in 18th century. Was modified to its modern form in the mid-19th century by French scientist Henri Darcy. It is widely used to determine the airspeed of aircraft, water speed of boat, to measure the liquid, air, gas, flow velocities in a certain industrial applications. Working, so PITOT tube or PITOT static tube is an open-ended tube where moving fluid flows in order to measure the stagnation pressure. It is usually mounted under the wings of aircraft. PITOT tube is then connected to the diaphragm, which expands and contracts depending on speed of the air. So now let's see the diagram of this PITOT tube and advantage and disadvantage of PITOT tube. Advantage of PITOT tube is low cost, low permanent pressure loss, ease of installation. Disadvantage, low accuracy, low rangeability, requires the clean liquid, gas, vapor, as holes are easily clogged. Now see the diagrams from the left part, that is a velocity. Where it is from this left part, your fluid is inserting here, and here we are measuring the velocity v. Then this is your density, and that white part and yellow part is there, and in white part where we are measuring the total pressure, at yellow part we are measuring that static pressure, and their difference between pressure is known as a differential pressure. It is also shown by delta P. V square velocity we can find out by using this formula. V square equal to 2 into Pt minus Ps by P or by rho. So by using this formula you can find out the velocity. So this is your PITOT tube. Now next, another important equipment that is known as a variable area rotameter. So rotameter is a device that measures the volumetric flow rate of fluid in a closed tube. It belongs to the class of meter called variable flow meter, which measure the flow rate by allowing the cross-sectional area of fluid travels through a vary, causing a measurable effect. It was invented by scientist Carl Cooper in 1908. Rotameter consists of taper tube, typically made of glass, with a float inside that push up by drag force of flow and pull down by gravity. Higher volumetric flow rate through a given area increases the flow speed and drag force, so that float will be pushed upwards. However, as inside of rotameter is cone shaped, area around the float through which medium floats increases. So floats are made in different shapes, with sphere, ellipsoids being the most common. Float may be diagonally grooved, partially colored, so that it can rotate axially as fluid passes. Float must not float in the fluid. It has to have higher density than fluid, otherwise it will not float to top or top even if there is a no flow.